and welcome. In this video, we're going to look at how to solve this question using Geogebra, which is a free online calculator that anyone can access by going to geogebra.com or searching the internet for Geogebra. There's also an app for cell phones, iPads, laptops, and the like. So one way we can solve this question is, well, let me back up for a second. Let's read the question. It says construct a binomial probability distribution table using n equals 5 and p equals 0.21. Next, record the mean and standard deviation of the distribution below. Where necessary, round all numbers to 4 place values. The x value is the random variable that we are trying to identify. And in this case, the random variable is going to be representing an outcome. Since it's a binomial, there are only two outcomes, either success or failure. We can just label it as such. We can go into more detail, but we don't really need to. It's either success or failure. The success rate is, or its probability of success is 0.21, and any one successive trial. So we have 5 attempts or 5 trials, which means that we could have 0 successes and 5 failures, or 1 success and 4 failures, 2 successes and 3 failures. I skipped it again. 3 successes and 4 failures, 4 successes and 1. I can't count. I can't keep doing this with these numbers. And then 5 successes and 0 failures. All right. Now that we've got that figured out, we could have 0 outcomes, or 1, or 2, or 3, or 4, or 5. So our x value could be 0 through 5 inclusive. And what we're going to try and do is figure out what the probabilities of each of these are. Now, these probabilities are calculated with a binomial probability. There are 2 ways of doing that. The first way to do that is in Geogebra. If you download the calculator suite, you can click on the hamburger or the menu and click to switch calculator. When we switch calculator, we can go to the probability calculator, which will pull up the probability calculator. I don't know why it doesn't want to go split screen well. We've got it now, though. We click on distribution to bring up the distribution. I'm going to hide the graph because we don't need the graph for this. We would change the distribution to binomial because we're working with a binomial probability. We're not working with a cumulative. If we were, we could select cumulative here, but we're not working with cumulative. Our parameter n is 5, which we have. Our probability of success is 0.21. So I already have decimal point, 0.21. And we're looking for each of these outcomes. So we could select 0 from 0 to 0, and we'd find that the probability of 0 would be 0.3077. Then we could change this to 1, and this to 1, which would be 0.409. And then we could change both endpoints to 2, which would give us 0.2174. And then we could change this to 3. I think you get the hang of this. 0.0578. And then we could go to 4 and 4. 0.0077. And then 5 and 5. So a little tedious here. 0.0004. So that's what we could fill in the table. We also could use, if we switch calculator again, we also could use the graphing calculator entry. I'm going to hide the graph again because we don't need the graph. In input, we're going to type in binomial dist, which is the binomial distribution. And there's a couple of different ways we could do this. We could do either the binomial distribution with number of trials, which is n, and probability of success, which is 0.21 rather. Or the binomial distribution with number of trials, probability of success, and the cumulative Boolean, or the list of values. It doesn't really matter which one you choose, because we can change them all however we want to. So we have 5 trials with a probability of success of 0.21, and I didn't mean to press enter. Now we need to tell it what the outcomes are that we want. So in this case, we could either use the curly brackets and type in the values. In this case, 0 is 0.3077, or 1, which is 0.409, which is the same value we had before, and then 2, and keep changing this. Or if we don't use the curly brackets, we can just enter the value 2 and then type in the word false. The false would be whether or not it's cumulative. You'd have to type in the false for these. It's either curly brackets or false. So 0.2174, and again from here we could just change this from 2 to 1 to 0 to 3, and we get all the same values. So that's how we can calculate the values in the table based off the binomials. The next question asks us to find the mean and standard deviation. Again, there are 2 ways of finding the mean and standard deviation. We could let any variable we want. In this case, I'm going to let the variable be v for the word variable. V equals, and then curly bracket. We would type in 0, 1, 2, 3, 4, 5. And then underneath this, we could say P equals, and grab the curly brackets. And here's where we would put in the probabilities. So 0.3077, comma, 0.409, comma, 0.2174, comma, and I'm just putting in the probabilities from the table corresponding with each of the variable values. Notice I did not use the letter x. X and y are defined to be specific algebra terms in Geogebra, so if we typed in x, which is our random variable, we would get a little issue here. So we're going to use any letter other than x. Let me just finish typing in the rest of these. And now we can find the mean of v comma p. I should be using the on-screen keyboard, even though I'm using my laptop. Oops. So that means that the mean here is 1.05. And then we could find the STDEV, keep forgetting to use the on-screen keyboard, of the population, because we need to deal with population variables when we're calculating these, of v comma p, so we're using both values here, and that gives us the standard deviation of 0.91, 0.91. Now, if you are familiar with statistics, you know that there is also a formula that we could use. The formula is n times p. So in this case, n is 5 and p is 0.21. We also could have found the mean by just doing 5 times 0.21. Now in GeoGebra, it's always going to give you a fraction. If you click the blue equals to sign over here, or approximation sign, it will show you what the decimal approximation would be. And the standard deviation formula is the square root of n times p times q, where q is equal to 1 minus p, or the complement. So here we would type in the square root of 5 times 0.21 times, and I'm just going to be lazy here and just type this in directly into parentheses, 1 minus 0.21, whatever that would be. And you'll see that we get pretty much the same exact value. No, we get the same exact value. I thought it was going to be off a little bit because our values here were rounded. 0.2174, or this 0.409 was actually 0.4089758505. We just rounded it to 3 decimal places. So I thought these were going to be a little bit off, but they're essentially the same exact value, which is fantastic. So that's how we can find the mean and standard deviation using GeoGebra. Thanks for watching.